DI is the image distance. So whenever you use letters, please define your letters. Okay. So yesterday we also looked at lateral magnification and linear transverse magnification. Lateral magnification is a ratio of image distance over object distance image distance is U, object distance is V. So that is the ratio for lateral magnification. Then transverse magnification is also a ratio of image height over object height. In yesterday's ray diagram, we represented image height by H subscript I and object height as H subscript O. Okay. Then experiment and theory or geometry is or has proven that lateral magnification is always equal to the transverse magnification. And so we conclude that V over U is equal to HI over HO. This is what is equal to the linear magnification of curved mirrors. Linear magnification small letter m. So in short, m, which is the linear magnification, is equal to V over U, and is also equal to HI over HO. Now, when you find the magnitude of linear magnification and the value of linear magnification is equal to 1, we say that image size is equal to object size. And this is what happens, or image height is also equal to object height. This is what happens in images formed by plane mirrors. Okay, for images formed by plane mirror, linear magnification is equal to 1, meaning that U is equal to V or HI is equal to H naught. So when magnitude of linear magnification is 1, that is what it means. If the magnitude of linear magnification is greater than 1, image Saki.
Mistake.
It's a mistake.
Yes, sir.
So if the magnitude of image magnification, linear magnification, is greater than 1, then it means that V, let me clear using, so it means that V is greater than U, or HI is greater than HO. And here we say that image is magnified or enlarged. Image is enlarged, or magnified. So when an image is said to be magnified or enlarged, then it means the absolute value of the linear magnification must be greater than 1. If, on the other hand, this is less than 1, then it means that V is less than U, or HI is less than HO. Then image is diminished. So these are what goes into the numerical value of linear magnification, whether it is equal to 1, greater than 1, or less than 1. Okay. Plus, let me quickly drop attendance. Our number is not as expected. So let me quickly drop attendance quickly. So then we continue.
Recording in progress.
Okay, Frank. Frank.
Sir, please, in the beginning you wrote the lateral magnification is U over V, but later you came to write is V over U.
Come again.
Sir, in the beginning you said the
Lateral
magnification.
No, it's a mistake. It's V over U. Thank you. So V over U. Object image distance over. Okay. I think we can continue. Elikem.
Sir, please, the lateral mark, the first one, you wrote U over V, and then the second time you wrote V over U.
It's been corrected. It's V over U. Okay, it's V over U.
Okay, thanks.
Frank. Oh, it's a okay. All right. So that is what the meaning of, or the interpretation of, numerical value of the linear magnification. Okay. Now, In applying the mirror formula or equation, the mirror formula itself is 1 on F, 1 on U plus 1 on V. We can also modify this equation using the relationship between radius of curvature and the focal length. Radius of curvature is equal to 2 times the focal length. When I make F the subject in the radius of curvature equation, F is R on 2. I can substitute it into the mirror formula to have 1 over R on 2 is equal to 1 over U plus 1 over V. So that this becomes 2 over R is equal to 1 over U plus 1 over V. This is another way of expressing the mirror formula. Okay, we can also express the same mirror formula in terms of the linear magnification. Linear magnification, and this is lateral magnification, is equal to V over U, image distance over object distance. So within the equation, we want to make provision for V on U. So all that I do is that I want to have V on U within the equation. So I multiply through by V. So V times 1 over F. This is equal to V times 1 over U plus V times 1 on V. This will be V on F is equal to V on U plus 1. Because V on U is equal to the linear magnification M, I can also express the same equation as this, so that V will be equal to F times M plus 1. So if you see this, it is the same mirror formula, which is expressed in terms of linear magnification. All right. If you say this, just does it. It can also be in terms of, please, are you done writing?
No, please.
All right, so hurry up.
Recording in progress.
Frank, your hand is up.
Sir, please, why multiply each term by V?
No, we just want to have within the equation V over U. We can also decide to multiply through by U. So we multiply through by V because we want to have V over U to enable us substitute the linear magnification. Are you okay?
Yes, sir.
Please, are we through?
Yes, please. Yes,
Yeah.
please.
Okay. All right. So we can also, earlier we multiplied through by V. We can also multiply through by U. And when we multiply through by U, we have U times 1 on F is equal to U times 1 on U plus U over V. And this will be U on F is equal to 1 plus. Now U over V is the inverse of magnification. Don't forget linear magnification is V over U. So when I turn it upside down, I have 1 over M is equal to U over V. And so wherever I see U over V, I can substitute 1 over M. Okay, so this is another way of expressing the same thing. So when you make U the subject, this time you have F times 1 plus 1 over M. Okay, another way of expressing this. So in books, you will see these things. Pardon?
Can you explain it? Can you explain the part to introduce the 1 over M again?
All that we are doing is that we want to express the linear, the mirror formula in a different way. Okay, so earlier we multiplied through by V just to have V over U and substitute M. And this time around, when we make U over V the subject, we'll have 1 over the linear magnification. So within the mirror formula, all that we are interested in doing is to have U over V so as to enable us substitute 1 over M. So we multiply through by U. U times 1 over F is this. Okay, U times 1 over U is 1 plus U times this is U over M. Okay, and because 1 over V, because 1 over M is equal to U over V, we substitute 1 over M in place of U over V. So we have U over F is equal to 1 plus 1 over M. That's all. So we are basically expressing the mirror formula in different forms, in terms of V or in terms of U and the linear magnification. All right. Now, let's look at application of this mirror formula. Why do we use the mirror formula? We use the mirror formula to also describe the nature of the image formed aside ray diagram. So we can use 2 things to describe the nature of the image formed in spherical mirrors. 1, using ray diagram, and 2, using the mirror formula. Okay, so we can also use the mirror formula to describe the nature of the image form, whether the image is real, whether the image is virtual, whether the image is magnified or enlarged or diminished. Okay. So that is, yesterday somebody asked, why the mirror formula? Yes, we use the mirror formula also to describe the nature or the characteristics of image formed aside the ray diagram as we learned. Now, in using the mirror formula, its application comes with a certain rules which must be understood and applied alongside the mirror equation or formula. These rules are termed as conventions. So rules or conventions. So these are rules that are used alongside the mirror formula. We have two key or two main conventions. One, we have RP convention. And RP means real is positive. Anything real is positive. So RP convention simply means real is positive convention, meaning anything real is positive and anything virtual is negative. So it implies that anything that is real is positive. Who has not muted? Asida, mute yourself. So anything real is positive, anything virtual is negative. Alexander, mute yourself. So in RP convention, real objects, real image, real objects, real image must be considered to be positive. And virtual objects virtual image must be considered to be negative. That's the meaning of RP convention. So all measurements, meaning that all real measurements are positive, all virtual measurements are negative. If the thing is real, then it must be positive. If it is virtual, it must be negative accordingly. So let's draw a spherical mirror and then try to understand this properly. So this is a pole. This is a principal axis. This is a concave mirror. A concave mirror has a real principal focus. A concave mirror has a real principal focus. A concave mirror has a real center of curvature. Meaning that for a concave mirror, F and R are always positive. Okay, so for a concave mirror, F and R are always positive because they have real principal focus and real center of curvature. Object is always real. It's a real object that is placed in front of the mirror for light to incident and then gets reflected. So U is positive because objects, we are always dealing with real objects. What about V? V being positive or negative will depend upon the nature of the image formed. So as for V, it is dependent on the nature of the image formed. Now V is positive when image formed is real. When image formed is real. And V is negative when image formed is virtual. So this is what goes into RP convention. Okay, anything real must be considered positive. Anything virtual must be considered negative. So if for concave mirror, F is real, meaning paraxial rays actually converge on the principal axis. Object is always real. Object is always real. But V will depend on the nature of the image form. If the image is real, V will be positive. If image is virtual, V will be negative. Please, is there any question before we look at what goes into convex? Any question? No question. Frank, no question. Gideon, no question.
No, sir.
Hey, Yasmin, today you are here.
So I think I have one question.
Quick one.
So you said when the image is virtual, U is negative.
When the image is virtual, okay, V is negative under RP convention. So let's draw a convex mirror.
So it's not about the U.
Object is always real. Now for convex mirror, object is always real, so U will be positive. For convex mirror, would F be positive or negative? Yasmin, the question is for you. Yasmin.
Yes, sir.
For convex mirror, would F be positive or negative?
The negative.
Why? Why negative? Okay, Michelle, why? Michelle, what's the reason? Okay, Frank, go ahead.
Please, because both are virtual.
Yes, because a convex mirror has a virtual principal focus or focal point. So for convex mirror, F will be negative. R will also be negative. Okay. Anita. Anita, are you there?
Yes, sir.
What about V for convex mirror? What will be the sign to V? Would that be positive or negative?
To be negative.
Anita, why?
Because it's formed behind the mirror.
Or yeah, describe your
It's the image is virtual.
so always forms a virtual image. Convex mirror always forms a virtual image no matter the object position. So V for convex mirror, V would always be negative. This is what goes into RP convention. Now, before we look at the other convention, I want us to use this in solving a question for the concept to stick. And I'm reading. Are you ready? Class, are you ready?
Yes, sir.
Okay. So an object is placed A, 20 centimeter. An object is placed A, 20 centimeter, B, 4 centimeter in front of a concave mirror B, 4 centimeter in front of a concave mirror of focal length 12 centimeter. Find the nature and position of the image formed in each case. Find the nature and position of the image formed in each case. Frank.
Sir, please, could you repeat the question again?
I'm coming. And position of the image formed in each case. So an object is placed A, 20 centimeter, B, 4 centimeter in front of a concave mirror of focal length 12 centimeter. Of focal length 12 centimeter. Find the nature and position of the image formed in each case, meaning you are doing that for A and B respectively. Okay. So we are using mirror formula to describe the nature of the image. Okay. So first, quote the mirror formula.
1 over F.
So 1 on F
is equal to 1 on U
plus 1 on V. Okay. Now the next thing you must understand is what is the kind or the type of mirror in question here? What's the type of mirror in question? Is it concave or convex? It's concave. Okay. It's concave. So it's a concave mirror or converging. If it's a concave mirror, then using the RP convention, the focal length F given to us will be positive. Object distance U will be positive because real objects. So this will also be plus 20 centimeter. You can decide not to write it. If you don't write it, means it's okay. So substitute, we are looking for V. So you can decide to make V, 1 over V the subject. 1 over V would be equal to 1 over F minus 1 over U. Substitute your values. 1 over 12 minus 1 over, we are answering the A first, 20. Okay. What will be the LCM? What will be the LCM? So basically 20 minus 12 by 240 can also do it. Even I think 120 would also do it.
60.
60 would also do it. Yes. So let's pick the LCM. Let's pick the LCM instead. So 60 will do it. And 12 into 65, 20 into 60. What's 20 into 60? That's 3. So we have 2 on 60, which is the same as 1 on 15. Therefore, V is equal to 15 centimeter. Now, note something. When we calculated, we are getting V to be positive. Once V is positive, then it means the image is real.
Sir.
Hello.
Sir, please, your final answer for the, yes, 1 over 30.
1 over 30.
Sorry, 1 over 30. So it will be 30 centimeter. So once V is positive 30, image will be real, and all real images are inverted. Okay. So that's the nature of the image. Now, the position of the image is that once the image is real, it means that the image will be at the same side as the object at a distance of 30 centimeters from the mirror. So if we are to even draw, Gideon, hold on, I'm coming. If we are to give a sketch, all measurements are taken from the pole. So focal length is here. And this distance from the pole is 12 centimeters. Object distance is 20, meaning the object, and you see, if F is 12, R will be 2 times 12, which is 24 centimeters. So this will be the position of the center of curvature. So if object is 20, then the object is between the center of curvature and F. And we saw that whenever an object is placed between C and F, the image is real and inverted. Okay, so because V is greater than F and V is less than, V is also, hold on, V is 30, meaning is behind, it will be behind C. V is 30, meaning it will be beyond C. And it must give us a real image that is inverted. Is that okay? So we can just use whatever we got for V to determine the nature of the image formed. This is how to apply the mirror formula. Gideon.
So can you also say the nature of the image form will be diminished?
By using the ray diagram, yes, you can use that to also judge the nature of the image. Okay, at least you understand ray diagrams, that when an object is beyond C, okay, the image will be formed, blah, blah, blah. So that's it. Are you okay?
Yes, sir.
Saki.
Sir, please, we learn in a concave mirror, the images are formed in front of the mirror.
Yes.
To say the distance from the pole to the center of curvature is 24 centimeters.
Yes.
To say the image takes up 12, and when you add 20 to it, you get 32, sorry. To say, isn't that beyond the center of curvature instead of between?
It's beyond the center of curvature because the image distance is 30. Center of curvature is 24. So it means that the image will be located behind C, and that's what I've drawn. Are you okay?
Yes, sir.
So you are only using the values to judge the nature of the image form. Angie, quick one.
I don't understand the diagram you've drawn.
Okay. Our focal length is 12 centimeters. All measurements are taken from the pole. So from the pole, I must measure a distance of 12 centimeters. And that will be the focal point or principal focus F. Okay. Our object distance is 20. So 20 from the pole, if I measure 20 centimeters from the pole, that will be the location of the object. So I'm only assuming that this distance is 20 centimeters. Okay. So we use the mirror formula and then got the image distance V to be 30. Meaning if you measure 30 centimeters from the pole, that will be the location of the image. And that is what I have here. And once V is positive, the image is real. That's why I've inverted it. Is that okay? Angie, is that okay? Now, how did I know that it will be behind C? R is equal to 24. So if you have V to be 30, it means that the object is about 6 centimeters away from, the image is about 6 centimeters away from C. That's the whole idea. Okay, class, I want you to try the B question where object distance is 4 centimeters. So do it, calculate the image distance and then determine the nature of the image. About 2 minutes must be enough for this. Two minutes must be enough. Yes. What's the image distance, Elikem?
The pizza V is equal to -6 centimeters.
V is equal to
-6.
Okay, that's Elikem's answer. Frank.
So I also had -6.
And then another one from a lady. Gender balance. Yasmin.
Also had -6.
Thank you. You see, so once V is negative, it means the image is virtual. Even before calculation, I can use this to judge. The focal length F is 12. And object distance is 4. It tells me that U is less than F. If U is less than F and I sketch something, even without going through the calculation, I could easily see that, oh, okay, if assuming this is F and this is 12, and object distance, all measurements are taken from the pole as 4, then it means the object is somewhere here. It's between the pole and F. And from our ray diagram, whenever an object is between the pole and F, a virtual image will be formed. And that's the only condition where the image will be virtual for concave mirror. Okay, so I'm just using the values. And then perhaps find V 1 over F minus 1 over U. Okay, so 1 over 12 minus 1 over 4. And I have LCM 12, 1 minus 3. And this is negative 2, which is 1 over 6. Therefore, V is equal to negative 6 centimeters. That is the power of this convention. Any question? Any question, class? No question. Let's look at the other convention. The other convention, which is the NC convention. Elikem.
Sir, please, if you draw this one, will the image be between F and P?
Hey, Elikem. You've done ray diagrams, so. Okay, let's draw. Let's just sketch something. So this is a focal point, and this is the center of curvature. Because U is less than F, object must be here. And whenever an object is here, it will always give us a virtual image, which is behind the mirror. Okay, so the image will be a distance of 6 centimeters from pole behind the mirror. And let's using ray diagram, a ray of light parallel to the principal axis after reflection oh, my ray is not must be parallel to this, must pass through this. An array of light from the object passing through this must also pass through C. No, the ray is not. So arrow, the incident ray must come from the reflected can be behind. So incident, reflected. The rays will never meet in front. And so let's extend the reflected rays backwardly. So it would be at a distance of 6 centimeters from the pole at the back of the mirror. So this distance from the pole must be 6 centimeters. And it's negative because this measurement is behind the mirror. Alekam, are you okay?
Say, yes. I actually meant the object, no.
No, the object is 4 centimeters from the pole. So here, this distance must be 4 centimeters. All measurements are taken from the pole. Don't forget. All right. So the next convention is the NC convention. And NC means New Cartesian Convention. Okay. And this convention states that please do not forget that all measurements are taken from the pole. So all distances are measured from the mirror or the pole of the mirror as the origin. So in the New Cartesian Convention, 1, please give me a minute, I'm coming. So under the NC convention, 1, all distances are measured from the mirror as the origin, just as we do for convex, a RP. So all distances are measured from the mirror from the pole of the mirror as origin. 2, distances measured against the incident light are negative. Distances measured against the incident light are negative. I will explain. So yeah, just put the points down, after which I'll throw more light. And then distances measured in the same direction as incident light are positive. So this is basically what goes into the NC convention. Let me clear this side and explain to you what I mean by all that. So let's take concave mirror, for instance. All that the convention is saying is that there is a pole and all measurements are taken from the pole, whether concave or convex. Supposing the object is here, from the pole to the object, this distance is the object distance. Okay. Class, are you there?
Yes, please.
So
Yes, please.
light must move from the object and then incident on the mirror. So look at the direction of incident light. If I'm supposed to draw, there's the direction. So the direction of incident light is here. Now, if I'm to measure the object distance, because all measurements are taken from the pole, my object distance will be measured from this direction. The origin of measurement is the pole. So it will go in this direction. Okay. So look at the direction of incident light. And then the direction of distance measured. So look at the first point. All distances are measured from the pole of the mirror as the origin, or slash reference. And 2, distances measured against the incident light are negative. So straight away, because the direction of measurements of U is against the direction of incident light, it means that under this convention, U is equal to negative. If the image form is real, V would certainly be negative. For concave mirror, because its principal focus is real, occurs in front of the mirror, F will also be negative. So is R as well. Class, please, are you following?
Can you explain that part again?
So under this convention, all distances measured against the incident light are negative. So supposing a real image is formed, a real image must be formed in front of the mirror, inverted. Supposing a virtual image is formed, a virtual image must be formed behind the mirror. So under this convention, because a concave mirror has a real principal focus, if we are to measure F, we'll move in this direction. If we are to measure object distance, it will move in this direction. If we are to measure image distance, and if the image is real, we must move in this direction. So all distances that are against the direction of incident light must be negative. So under this convention, for concave mirror in particular, UFR will be negative. However, V will depend on the nature of the image form. If the image form is real, V will be negative. If the image form is virtual, this is how I'll measure V. If the image is virtual, it will go in this direction. And the direction of measurement this time is in the same direction as the direction of the incident light. So in this particular situation, when the image is virtual, V will be positive. Class, this is the meaning of the convention. Please, are you okay? Hello, are we okay?
No, please.
Let's take concave 2, convex mirror, and see, apply the same thing. Nana Kumi, Aniwa. This time I don't get to hear from you people, and it's so bad.
Sure.
These days, you people do not speak. What is your secret? So for convex, you see, its principal focus is here. Center of curvature is here. Object is always placed in front of the mirror, where a place at where the reflecting surface is. So look at the direction of the incident light. The light must always come from the object. So the direction of the incident light will be in this direction. All measurements are taken from the pole. So if I'm to measure the object distance, it will certainly go in a direction against, because it's the object, in a direction against the direction of incident light. So straight away, by this convention, U is negative. Okay. U is negative. If I'm to measure the focal length, because the focal length is virtual, this will be the direction of measurement. So the direction of measurement will be in the direction of incident light. So straight away for convex mirror, F, under this convention, F is positive. R will also be positive. Now class, what about V? Will V be positive or negative? For convex mirror, would V be positive or negative? Hey, who is talking? Free will.
Positive.
So V will be positive because this mirror would always form a virtual image, which is in front, behind the mirror. So V will be positive. And just this simple. Now, if it happens that for the NC convention, if it happens that whether concave or convex, the object is always placed at the left-hand side, if it happens that the object is always placed at the left-hand side, then, so look at, this is convex, this is also concave. We have deliberately placed the object at the left-hand side. Then, if always the object is at the left-hand side, then it follows the Cartesian plane. Whatever we do in the Cartesian plane, the XY axis. You see, in your XY axis, if this is the origin, which is the pole, if this is the origin, then all measurements along the negative X are negative. This is negative X axis, positive X axis, negative Y, and positive Y. So if it happens that the object is always placed in front of the mirror, or the object is always placed at the left-hand side, then it simply follows whatever pertains in the Cartesian plane system, where all measurements to the left are negative, all measurements to the right are positive, respectively. And then up and down in that one. Class, are we fine? Are we okay?
Yes, please.
We are looking at this rule because we can't also rule out the convention that, you see, sometimes we can also draw a mirror. This is, let's shade the back. This is concave. This is concave, and decide to place the object here. It isn't all the time that the object will be placed at the left-hand side. It can change. It can also be placed here. Okay, so if it is this, then this will be the direction of the incident light. This is the direction of incident light. The light or ray must always come from the object. So once is the pole, all measurements all measurements against the direction of the incident light, negative. All measurements in the same direction as the incident light are positive. So no matter the orientation of the object, we can still apply the law and then use it accordingly. Okay. Now let's use the same question we solved. Let's use the same question we solved for NC convention. So I'm repeating the question for the sake of those who perhaps joined late. An object is placed A, 20 centimeter, B, 4 centimeter in front of a concave mirror of focal length 12 centimeter. Find the nature and position of the image formed in each case. Find the nature and the position of the image formed in each case. So this time we are using the NC convention. So we have U as 20 centimeter and 4 centimeter and F is 12 centimeter. Okay. The mirror in question is concave or converging mirror. So using NC, whether NC or RP, you must have the same value. Using NC, Saki.
Is there a case where if like you choose to use any convention, but the image is before the object?
Your question is not clear.
Is there any case where the position of the image will be formed in front of the object?
Yes. Yes. If you place objects beyond C, image will be in front of the object. Okay. If you place object beyond C, the image will be formed between C and F. Okay, so let's use our convention. This is a concave mirror. So supposing wherever the object is placed, if object is here, 20 centimeter, I'm assuming this is F, so this distance from the pole is 12. So if that's 12, then C will be here. So it means that the object will be in between. There's the direction of incident light. And so my object distance, because it must be this O, it must be in this direction when I'm measuring, straight away U is negative 20. And F would also be negative 12 centimeter. So let's determine V. So 1 on F is equal to 1 on U plus 1 on V. 1 on V is equal to 1 on F minus 1 on U. Now, what is F? F is minus 1 over 12 okay, because F is negative, minus 1/20. Please, I hope you understand the minus. Class, are you following?
Yes, please.
Yes, please.
When I made 1/V the subject, I had 1 on F minus 1/U. By the convention, U is negative. So that's why I have the minus. Okay, so we have negative 1/12 plus 1/20, or 1/20 minus 1/12. The value is the same. So LCM 60. Okay, 20 goes into 63. 3 times this is 3. Minus 12 goes into 60. 5 times 1. This is 5. So we have negative 2/60. And this is equal to 1 on V is equal to negative 1 on 30. V therefore is equal to negative 30 centimeters. Now the fact that this time around V is negative means that the measurement of this V must be against the direction of the incident light. So when we are measuring this, we must go in this direction, against the direction of the incident light. That is where the image will be. So image clearly S, real. All real images are inverted. Let's also solve to see whether the image will be magnified or diminished. So magnitude of linear magnification is equal to V/U. What is V? V is 30. What is U? U is 20. Now, when you bring the magnitude here, it means that you are considering numerical value. The negative simply means that take your measurement in a direction against the direction of incident light. But in numerical terms, you consider the number 30. That is why I have this absolute value or magnitude here. So 30/20 is equal to 1.5. Okay. Now we are seeing the magnitude of the linear magnification to be greater than 1. Once it's greater than 1, image is magnified. Very simple. Image is magnified. So whether or enlarged, whether RP or NC, you must get the same thing. Any question? Then the B question, when U is 4, Gideon.
So please, when we're introducing the absolute value, so the M is equal to V/U, why do you make the 30 negative?
Hey, Gideon, I just said this. The reason why we write this magnitude, this line, and then place the M into this is that we are only looking at the numerical value, the number. The negative only gives us an idea that you must take your measurement of 30 against the direction of incident light. Okay, so if you are looking for whether it is magnified or diminished, you look at the numerical value, and that is why I place M in this line. So we are only interested in the number of V and U. That is why I didn't look at the negative thing. Simply, the negative simply means that image is real, because you must measure V against the direction of incident light. That is all. It is not that it is a smaller value or an unnecessary value, but it's just to give you an idea of whether the image is real or virtual. Class, I hope that is okay to all. Are you okay?
Okay, thank you. Yes, sir. Thank you.
All right. So when it is V is equal to, no, do that for me. When U is equal to 4 centimeters. And we've used RP, so it must give you the same thing. All right, another example. Okay, for the sake of the rest of us. So 1 over minus 12 is equal to 1 over minus 4 plus 1 over V. So 1 over V would be equal to negative 1 over 12 plus 1 over 4, when I make 1 over V the subject. Okay, or this is the same as 1 over 4 minus 1 over 12. In my SHS days, I wasn't a fan of negative, so I'll always write positive before negative. So LCM 12. 4 goes into 12, 3. 3 times 1 minus 12 will go into 12, 1. 1 times 1. So this time we'll have 2 over 12, which is 1 over 6. We have straight away V is equal to 6 centimeters. And V being positive means that, oh, then the image distance will be measured from a direction which is in line with the direction of the incident light. Look at the direction of the incident light. So we'll measure V, a distance of 6 centimeters from the pole. That's why it's positive. Okay. And the image must be magnified. Don't forget, the only time, excuse me, the only time a concave mirror forms a virtual image is when U is less than F. Let's see if the image will be magnified. Here, M is V over U. What is V? V is 6. U is 4. What is 6 over 4? 3 over 2. 3 over 2 is, what is 3 over 2? 1.5.
1.5.
So this value is greater than 1. Once it's greater than 1, image is magnified. Janelle, are you okay?
Yes, please.
Michelle, I wish I can mention all names. Paddy, Frank, Isaac, Samuel, Esau, Habakkuk. Okay, let's move on. Another question.
I don't understand.
Daniel, which part?
Hey, you heard me. Jesus. Say I'm fine.
You better be fine. Okay, another trial word. Another trial word. Are you there? Are you people ready?
Yes,
A convex mirror of focal length 18 centimeter.
Sir.
Hello.
Yeah. Sir, please, can we do like a quick brush through?
Oh, let's solve the question. Because I'll discuss it. Let's solve the question, okay?
All right, sir. But sir, please remember to send the
video
recording so that
I'll definitely do that, okay?
Thank you, sir.
Okay. So a convex mirror of focal length 18 centimeter. A convex mirror of focal length 18 centimeter produces an image on its axis. Here, the principal axis. Don't be confused. A convex mirror of focal length 18 centimeter produces an image on its axis. A convex mirror of focal length 18 centimeter produces an image on its axis 6 centimeter away from the mirror. 6 centimeter away from the mirror. Calculate the position and the nature and determine the nature of the. Hey, okay. Hold on. Hold on. I was trying to frame my own question, but I can't do that. A convex mirror of focal length 18 centimeter produces an image on its axis 6 centimeter away from the mirror. Calculate the position of the object. Calculate the position of the object using both RP and NC convention. So this time I'm pinning you to use both conventions. Calculate the position of the object using both RP and NC convention. This is your question. Start work. We have, I think 6 minutes. Wow, but start work. You are using the 6 minutes to answer this question. Frank.
Please, is the mirror concave or convex?
A convex mirror. A convex mirror of focal length 18 centimeter. So start work. 6 minutes. Our lesson ends at 5 o'clock.
Yes, sir.
Hey, I thought we'll end at 5:15. Okay, so finish it and then send it to me. Okay. Hello, class.
Yes,
Are you okay?
yes, please.
All right. Okay, so this is where we end the show. Please, you are not subscribing to the channel, some of you. So please do so. I'll send a video. So when you visit the channel, kindly do that for me. Bye-bye.
Bye.
I'll be expecting the
Bye.
results.
Yes, sir.
Okay, sir.